Hi, everyone. Welcome back to the Innovation Blueprint by Webisoft. I am your co host here today, Paolo Shishkovsky, and we have David Burks with us, who is the CEO of the Insight Ultrasonic. And I'd love him to get started and introduce himself. So, passing on to you, David.
Yeah, happy to. Thank you, Paulo. My name is David Burks. I'm the CEO of Insight Ultrasonics. We make ultrasonic-based, non-destructive test systems, and our target market right now is automotive, primarily because it's a big market, and there's a gap right now in that there's still a lot of destructive testing happening in the automotive space. Our particular product is designed to validate spot welds, and there's about 5,000 or 6,000 of those on every car out there. But we'll come back to that. My background is initially started out as a software engineer a long time ago, and worked in industry, both in commercial industry for Hewlett Packard, and then eventually for Seagate Technology. Spent a long time in the hard drive industry, but I moved from kind of the software development effort into kind of general engineering. So I'm kind of a general technologist, nowadays, but also went back and got an MBA with an emphasis in finance. So I kind of understand a little bit about running a business from a financial perspective. And I'm also kind of a serial entrepreneur. I've had a lot of businesses over the year, kind of sideline businesses or full-time businesses. And so it's kind of in my blood. So sitting in one now, this is a location where I'm a partner in a winery that I started a few years ago. That was kind of a passion business, but it's done very well. And it's a fun business with perks.
Yeah. It's definitely a fun business, for sure, the winery. But thank you. We're so happy to have you on this podcast. Obviously, this podcast specializes in innovation, and that's where our core topic here is. And so I'm sure there's actually a lot of interesting innovation happening in the winery. Maybe we'll dive into that a little bit later in the show. But I would like to kind of come back to Insight Ultrasonic here and tell me more about how you got started in the business.
Yeah, sure. A couple of my partners, who have also been involved with a couple of ventures, and invited me in to kind of fix a company. But Inside Ultrasonics they acquired a contract manufacturing company that came along with this little business that was sort of floundering. We picked up this intellectual property from a nonprofit think tank called the Edison Welding Institute, who does, a lot of welding research and is funded by industry, automotive, and a lot of other, related companies in industry help fund them. And so we picked up the technology from them. It was pretty immature, and so we initially had sold, some of those into kind of researchy institutions, but it wasn't very profitable. And so I came in to take a look at it and really decided we need to move it into kind of a more production-oriented kind of marketplace where there was more volume, more need, and more money to be made. So that's what we did. We selected kind of a little bit fortuitously. We got connected with a tier one automotive supplier company that was really wanting to get out of destructive testing for their products and wanted something that was automated. So that was kind of a little bit of a match made in heaven. So we spent a couple of years taking our technology and essentially upgrading it to be fully robotic and autonomous for this particular challenge in the marketplace. And it's a pretty big challenge. We estimate that there's probably worldwide as much as $2 or $2.5 billion still spent on destroying parts. It's interesting because these parts are typically structural parts, so they're closely related to safety, right? You don't want your parts to fall apart. They hold things together, and obviously the auto industry is very risk averse. They can't afford, to have failures in the business, especially failures that result in recalls and so on. So they're pretty risk averse, and so they still, because there's so many of these welds on a car, there is manual ultrasonic testing as well, but it's not really viable when you have a very large part that has all these tiny little welds on it, and a person to actually test those individually is just not tenable. So they do use some manual ultrasonic testing in the industry on smaller parts, but generally for the bigger parts they still destroy them, which is it's an expensive product process. It's kind of dangerous. It's one of the leading causes of lost time accidents in the business because they actually have to tear pieces of metal apart and then measure these little things manually with calipers. And so even though they destroy a fairly small number of parts, which is usually only somewhere between like 0.5% or 1% of the parts to validate, it ends up being a lot of money because those parts are scrapped, they can't sell them, and the labor and so on. So there's a lot of money spent on it.
So, as you mentioned, like there's a huge cost saving by using your technology. Tell us more about how these robotics work. I'm assuming they use ultrasonic waves, but maybe give us a little bit more of a description. What do they look like, and how are they implemented in the welding
Sure.
process?
Yeah, I mean, we use a kind of classic robotic arm. In the industrial robotics market, there's different classes of robots, but by far the most common deployment of robots are the large industrial robotic arms that have a mount point, and then they, have usually at least 3 axes of movement, and up to sometimes 7 or 8 axes of movement in them. But the hard part is, that these spot welds on these parts are quite small. They're smaller than a dime, the circumference of a dime. There's lots of them. They sometimes look very similar to a hole in the part or a bracket or something like that. So one of the big, innovations in the marketplace has been AI-based vision technology. So we've adopted that as one of our key enablers. So the vision technology, we train that technology for our vision cameras to recognize spot welds. We have a very large database of varied, parts and so on. So we can use that technology to generally find those parts very effectively. But we also have to train the parts. So our software has a module where we train the parts by moving the robot from the general location of where the weld will be, and we capture that information in our database, and then we use the vision camera to take pictures of the real part, and then we make adjustments in the positioning, and then we also can see the weld with our ultrasonic probe once we make contact with the metal, so we can tell if we're centered on it or not centered on it. We can make micro adjustments. So the net result is we can very accurately find every single weld, position our probe right over the top of it, take a measurement, and what we're essentially doing with that ultrasonic technology is we're sending sound waves through the metal, and the sound waves will bounce back when you hit an air gap, which means that you've reached either the bottom of the weld or a defect in the weld or something. So we can very accurately measure the thickness of the welds, excuse me, and the diameter of the welds, which are the two key parameters involved here. We also have very innovative machine learning code that can characterize those welds and can correlate I don't want to give away some of our technology, but we can correlate those images to passes and failures over time. So we turn that into predictive failure, which is super important for this industry because today, mostly of what they're doing is testing a small number of parts that come off the manufacturing line, validate that their process at that point in time is still good, and then they make a bunch of parts. And then, they might make another 100 or 200 or 1,000 parts without doing another validation, and so that's the risky area. So through this technology, they can afford to test some more parts because they're not destroying them, so they can sample over the course of a day or the shift or whatever, and then we can actually alert them much more proactively to when the process begins to not look so good, so they can take corrective action sooner and avoid making bad parts.
Okay, very interesting. So you are really sitting on so many new innovative processes. It's all from robotic to AI to obviously data collection and then inferring the data as well. Um, so where do you think the real innovation is happening right now? Is it in the hardware, the software? Is it in the sensors or the data layer, or is it kind of a combination of all of those?
All of the above. Yeah, the innovation, but certainly, AI is making a big difference because AI assisted coding obviously just is a big productivity tool. but it's also a tool that is being used to understand and allow incremental improvements in coding that otherwise might not be intuitive to humans. But generally, it's all of the above. Obviously, chip technology, obviously, in the AI sector is making things much more powerful. And for example, in our case, we're using kind of a light machine learning kind of technology to do our predictive failure stuff, but we will progress to a more cloud-based learning model that will take into consideration even more of the variables associated with the weld to give us a more powerful and accurate inference engine. And all those things add up to just higher quality in manufacturing, higher quality plus avoiding not really very productive labor. So destructive testing is a great example of that. I mean, most of the manufacturers hate to do destructive testing. The people doing it are not really fond of it. They'd rather put them to work on much more important tasks, but they don't have a good alternative. So, labor is a big part of that, but it's really the not too value added labor that I think the technologies are going to circumvent.
Yeah, so from what you're saying here, David, it sounds like Insight Ultrasonic is able to save a lot of time in the process of checking the welding parts that a lot of the labor doesn't want to do, or isn't necessarily, like, the manufacturing isn't looking to proceed with that, or they have to proceed with it, but it's not the most exciting labor job. And so just out of curiosity, how does the cost of Insight Ultrasonic compare to having it being done right now in-house the way it is?
Yeah, that's a great question. What we have found with our primary customer is that we're able to save them at least 50% of the cost that they're spending on destructive testing, which adds up to a lot. Destructive testing is an interesting animal in that you're actually taking what is most likely good parts and destroying them. So there's a scrap cost, there's an opportunity cost because you could otherwise sell that. The labor expense is actually a fairly small component of it, but it's indicative of a lot of things that are happening in manufacturing where the controls of manufacturing that are tighter and tighter. So we're creating more real-time loops of make, measure, validate, and so on. The example I gave a little bit a while ago to talk about, they're testing these parts when they come off the manufacturing line and then they make a bunch more that where they're kind of blind, right? And if something happens to the process in that interim, they don't have, a great way to necessarily catch it. That's really emblematic of our industry, but it happens in a lot of manufacturing cycles, right? And so I think this is where this combination of AI, new sensors that are being deployed in a variety of ways across manufacturing, and those can be sensors that are vision camera based, they can be other sensors that, distance measurement sensors or X-ray sensors or all kinds of different sensors that are gathering information real time that then can be turned into knowledge and help you manage a process real time with much, much more accuracy. So you don't have these blind spots that can pop up and really, cost a lot of money.
Yeah, no, 100%. And what would you say is, like, there's a huge conversation between robots and humans and how there's actually less errors on, like, the AI side or the robotics side, or at least that's what we're hoping to see. With Insight Ultrasonic, what has been, like, the margin of error so far, and what are you guys working with, and how are you improving that?
Well, that's a good question. Nothing's perfect.
Yeah, of course. Humans are not perfect. That's the other thing. Humans are definitely very imperfect creatures. So
we're working toward perfection. But in our case, what we're finding is that we average around 95 to 97% correlation to destructive testing, meaning that, we have to demonstrate to our customers and to their customers, if they're a supplier to, a major OEM or something, that the process works. So to do that, we do correlation testing. So they will test on our system non-destructively, and then that part will go to a destructive cell, and they'll tear it up and they'll measure it. And what we're finding is over 95 to 97% right now. We're running closer to 97% correlated. Now, why not 100%? Well, part of that is that the destructive testing in itself is sort of subjective, right? Because they're literally pulling things apart, measuring a little piece of metal with calipers, and sometimes it's dead nuts on, sometimes it's not. But that's a very high level of correlation in this industry, and so it's providing a lot of validation that the process works well. Now, ultrasonic testing has some challenges associated with it where it can be fooled a little bit, but they're very corner cases, and we're learning more and more through this other mechanism, which is the machine learning and the stuff that we train in the cloud and stuff. So where we can detect those things where the typical testing that we're doing with the ultrasonic probes are not necessarily seeing that. So it's kind of interesting that's where the AI becomes really important, because sometimes these inference engines, they're like, well, gosh, they're right. We just don't know why they're right. That's the situation.
Yeah, because you're consistently training the AI model on new parts and different types of errors that can occur as well. Okay, very cool. And then so you're also able to save, I'm assuming, a lot of materials because there's so much less waste because you're able to.
Yeah, a lot of materials.
Yeah. So a lot of saving costs on creating materials, buying materials, and.
Right. It's not a lot of materials in the grand scheme because, like I said, we think that the average destructive sample is about 1% to 1%, sometimes higher depending on the technology. If you get into something like aerospace, they're probably going to be testing every single part. They're not destroying them, but they'll be testing every single part because, that's very few parts, but really expensive. Whereas in the automotive industry, things are not quite as expensive, but lots and lots and lots of them. So the expense can vary by industry, but it's always expensive to make bad stuff. So, scrap and loss opportunity are big deals. And so to the extent that you can dramatically reduce those categories, you're going to have a winner.
Okay, very interesting. And so currently you mentioned you work with automotive industries. What other industries are you hoping to work with in the future?
Yes, there's other industries beyond automotive that automotive is kind of our beachhead, where we really want to get traction there first. We're a startup and we're still, early on. And so we are definitely trying to perfect our first implementation of our technology, but there's definitely opportunities to expand. For example, right now our technology is focused on spot welds and projection welds, but there's also seam welding that is done and so on. And we could use the same technology with different probes and then different software to stitch different components that are tested together, and then those would be additive incremental market opportunities.
Yeah. Very interesting. And so kind of coming back to a little bit more about the data aspect and all the data that you're capturing from the LLMs and machine learning, how do you think that will affect the industries itself?
Well, I think, data is critically important. And, coming from the hard drive industry, we used to want to be invested in anything that would grow data. And right now, data growth continues just to be immense. Because all that data represents information, and selfishly from a CEO of a startup, the data that we're using to validate these processes and so on, it really makes us sticky, right? Because that data represents information that is directly correlated to the effectivity of a manufacturing process. So it's not to say that we couldn't be replaced, but it definitely is a component of value, right? The value to us in terms of utilizing that data to consistently refine our processes and our accuracy, but also that data as an element of value that to us, it keeps us sticky with our customer and makes and gives us, better opportunity to stay in that role for a longer period of time.
No, 100%. And the other thing is that you're clearly bringing innovation to some older manufacturing industries or older kind of stuck in their ways industries, how are they reacting to the technology? Are they open to innovation? Are they looking to improve? And what's been the general
Well,
consensus?
it depends probably on the market. In our case, we had our first solution was approved by a major EV company that
Mm,
the leading one in the United States. You might recognize them, but they're more quick. They're a newer company. They were more quick to adopt this technology. Where you get into some of the older companies, and they have a little bit more institutional memory. That where they have they're maybe not as willing to pivot to something, so they want more proof and more validation and so on. So, for example, right now we're working on a project, major OEMs, and all of their current information about acceptance of ultrasonic testing is based on training operators. Well, we don't have operators in our system. It's all the decisions for pass and fail and so on, and so finding welds and placement of the probe and everything is automated. So, that's a big mind shift for them. Oh, we don't have to have all these trainings for these operators to learn how to read analog signals and things of that nature. Um,
hmm
so it's all automated, but it's being demonstrated to be very accurate. So, but they got to get over that hump and make sure that any changes they make are not going to put them at risk, and that's where the risk averse component comes in for them.
Yeah, that makes sense. And so right now, people who are using you, would they utilize the technology and then still maybe have somebody do a final check kind of at the end, like have a human check at the end, or is it kind of like a mix or just
Well,
100%?
it's we're kind of still in the infancy, but what we expect to happen is we're going to be going through substantial validation phases with these correlation studies. And once we reach those correlation study conclusions, there should be an approval to use it in an ongoing way. Now, they might kind of feather that in over time. So we're going to say, okay, we're good. Like our first, engagement we had, they said, we're good. Now you can switch over to using non-destructive testing. We might say, okay, well, now we're going to cut that back. And instead of testing 50 parts a day, we're going to test 10. So we'll see how that goes. But, our belief is that we need to have a paradigm shift in this particular market so that they start to adopt more testing, but lower cost testing, because they're not going to be destroying parts. So we want them to say, sample more, sample across a period of time that represents your entire manufacturing framework. And that allows us to help manage your process much more accurately and keep the quality much more even, right? And for example, we can even audit test. We can take parts and just test a portion of the welds on that particular part, pass it on. And then on the next part, we can test different welds, pass it on, and so on. And after a population of those parts moves through, now we've tested all those welds on an array of parts, and it gives you a statistically high set of confidence that your process is still in control.
You're clearly sitting at the pinnacle of innovation with robotics and trying to change the way industries are going to function in the future. And I'm curious because a lot of people are talking about robotics and how that's going to affect, the workforce and, are they going to attack the world? Is it going to be,
Yeah.
something crazy? But there's obviously a lot of stigma around it, a lot of, news and that just is flashy. But from your vantage point, what's the biggest misconception about robotics in your industry right now?
Well, I think, to a large degree, labor is fungible. And to the extent that automation is going to come in and displace some of that labor, that is a realistic certainty. But I do think that, we're going to have some shrinkage in the labor force. But I also generally agree that the productivity gains that we're going to have are going to, overcome that. And there's going to be a lot of other opportunities. Just for example, in robotics, stuff goes wrong with them. You have to keep them up. You have to caretake over them and so on and so forth, more so than you would some other not so complicated component, right? Because they get they have bugs in them once in a while. They have a piece of electronics fail. They need to be
Hmm.
so that part of the marketplace will grow, and it'll be a higher wage type of pool of people. So I do think that there will be an impact to the labor pool. It's necessary to make, especially the more sophisticated, advanced countries um, more able to compete with the lower cost countries. And so I think there's going to be kind of an equalization of that.
Mm.
But I don't think it's going to be severe. I think it'll be made up in part by better paying jobs and more efficiency.
Yeah, for sure. And so, kind of on that note, what would you suggest somebody who is just starting out? What should they focus on? Like, should it be more technical skills or just mastering AI or more like deep generalist knowledge? I know you mentioned you kind of become a generalist over
Yeah.
time.
I mean, I think the generalist knowledge is probably the safest bet. But we definitely need, deep technologists as well. Those are going to be specialists in things, whether that's physics or whether that's in chip design or whether that's in. So we need those people, but I think there's a lot more opportunity in the context of people who have more generalized skills that can apply to a lot of different industries. I think it makes you more marketable and more able to have a stable position.
Yeah, no, I would agree. I think definitely a mix of the two is important. And then here's my final question, because I am very interested about the fact that you also have a winery, and the winery obviously relies on a huge supply chain as well. If people don't know, we just kind of see the final product. But if you've ever been to a winery, you kind of see that it's a very supply chain process. Like it's very, very
Yeah.
procedural in the different stages of the wine goes through. So I guess it kind of actually makes sense why you pivoted to robotics. But tell me more actually about how those two
Well,
relate in the
that's a great
coalitions.
question. The winery thing was sort of a passion of mine. I used to make wine as an amateur, and I just wasn't happy with it. And it kind of grew, and I don't know. But ultimately, what we decided, my wife and I, and we had a partner back then. Now I have more partners because I sold most of the company to an operating company, but I'm still a partner in it. But the our vision, we're in Colorado, right? And we don't grow good grapes here. So we bring in our grapes from out of state. We bring in essentially California grapes, but we also acquire wine and stuff. So our thinking was that, gosh, if we built like a Napa quality type of experience in our region, you know, we would have something there. That was the general thesis. So we acquired some land and built a really beautiful property next to a river that flows through. It's a big timber frame, and it's just been very, very successful. People love to be there. They love to be outside. There's wildlife around, elk and deer and things of that
Mhm.
nature. Um, so we really we make good wine, and we have really high quality wine. So that's the key. It's interesting because the wine business in general is really kind of struggling right now because people are drinking less alcohol, and but in our region, we have very little competition, so we're thriving. We have a very large wine club of over almost 1,500 people, and it's growing all the time, and so it's kind of a fun business.
Yeah. And having a winery and just the history, like from what I've seen from past winery experiences, it's a very hands-on human experience. It involves a lot of human processing. Do you think it would ever be automated, or is that one industry, or not even one industry, but are there certain
That's a great
industries that just
question.
don't need that?
There's aspects of it I think that can be automated, and I'm sure there's some of that going on. But yeah, there's some definitely processing equipment. You have to acquire grapes, and for example, in the harvesting of grapes now, there's a lot of automation, right?
Hmm.
I personally like the hand pick grapes better because they're in better shape. Um, but but yeah, I think that'll be automation from an agricultural perspective is going to be transformative for sure. But yes, I mean, we're looking at automated bottling lines, for example, because right now we still use people to do a lot of that. So there's definitely components that are applying to all industries, but it's usually the parts of the business that are just uh, not as fun, really. Who likes picking a whole lot of grapes in the hot sun, and who likes, honestly, when we go to crush grapes every year, it's a sticky, labor intensive business that's still there, but that's kind of, it's once a year we celebrate it and have a good time. So
Yeah. Yeah. It's like fun for 5 minutes and then you're like, I'm over picking these
yeah,
grapes.
it's been a component of real happiness for me to be involved in that business. It's one of those passion things, and generally doesn't really align very well with my technology, history, but
Nothing has to match,
yeah,
there's
right,
no right or wrong. And to be fair, there's probably more similarities than people
right.
find that they're, yeah, with the supply chain aspect of it and everything else.
Yeah, for
But
sure.
yeah, I'm glad that wineries still exist in a sense that it gives people that experience and it's very personal, human, even if the background of it might have some manufacturing or robotics behind it at some point.
Yeah.
Hopefully we can still have the human aspect to it. But yeah, David, thank you so much for this conversation. This was really insightful. It really makes me think about the future and where we're all going with robotics, AI, software. Um, I'd love to give you the opportunity here to give people your socials, tell them more about where they can find you and connect with you. Yeah, feel free to go ahead there.
Yeah, no, I'm on LinkedIn, and our company is called insightultrasonics.com. You can find me there, and on LinkedIn, David Burks, Burks. Love to connect.
Awesome. Thank you so much.
My pleasure.